You can use the vertex form of a quadratic function, f of x equals a times the quantity x minus h squared plus k, to transform the graph of the parent function, f of x equals x squared. First, we'll consider the impact of a on the graph. We stretch or compress the graph of f of x equals x squared vertically by the factor the absolute value of a. We reflect the graph across the x-axis if a is less than 0. And now we'll consider the impacts of h and k. We translate or shift the graph, the absolute value of h units horizontally, and the absolute value of k units vertically. Take note, key concept, translation. So note this information, but we'll have more detail on the next few slides. First, the horizontal translation. Graphs can be shifted right or left. On the left-hand side, we see y equals the quantity x minus h squared, and we'll move the absolute value of h units to the right. The vertex, rather than being the origin, as it is in the parent function, becomes the ordered pair h comma 0. Now on the right-hand side, we see y equals the quantity x plus h squared. In this case, we'll move h units to the left. The vertex becomes the ordered pair negative h comma 0. Vertical shift. Graphs can also be shifted up or down. In this case, we have y equals x squared plus k, and in this case, as shown in the graph, we move the absolute value of k units upward. The vertex, instead of the origin, now becomes the ordered pair 0 comma k. On the right, if we have y equals x squared minus k, well, the graph moves the absolute value of k units down, and the vertex, rather than being the origin, becomes the ordered pair 0 comma negative k. Finally, horizontal and vertical. Horizontal and vertical translations can be combined to shift a graph right or left and up or down. So in the case of y equals the quantity x minus h squared plus k, we'll move the absolute value of k units up and the absolute value of h units to the right. Now the vertex, rather than being the origin, becomes the ordered pair h comma k. Now in the case of y equals the quantity x plus h squared minus k, we'll move the absolute value of k units down and the absolute value of h units left. The vertex becomes the ordered pair negative h comma negative k. Problem 4. Using vertex form. Part A. What is the graph of f of x equals negative 2 times the quantity x minus 1 squared plus 3? Well, in step 1, identify the constants. For us, a will equal negative 2, h will equal 1, and k will equal 3. Because a is less than 0, the parabola opens downward. Step 2, we'll plot the vertex at the ordered pair h comma k. For us, that's 1 comma 3, and draw the axis of symmetry at the line x equals 1. Step 3, we'll plot 2 points. We can choose an input value of x. In this case, 2 is chosen, and we evaluate f of 2. That equals negative 2 times the quantity 2 minus 1 squared plus 3, and that's 1. So we can plot the ordered pair 2 comma 1 and its symmetric point. Remember, symmetric about the axis of symmetry. That point is the ordered pair 0 comma 1. And finally, in step 4, sketch the curve. And part B is multiple choice. It says, what steps transform the graph of y equals x squared to y equals negative 2 times the quantity x plus 1 squared plus 3? Considering our options, the correct answer is D. First, stretch by the factor 2, and that will be a vertical stretch. Then reflect across the x-axis, accounting for the negative in front of the 2. It will translate 1 unit to the left. That's represented by the plus 1 in parentheses. And finally, 3 units up, the plus 3 on the far right, outside the parentheses. Your turn. What steps transform the graph of y equals x squared to y equals 2 times the quantity x plus 2 squared minus 5?